Hi everyone, welcome to this presentation. Very happy to be here. It's my first time giving this talk, so I'm always nervous the first time I give a talk, and then I tweak the slide up until like 20 minutes ago. So I have no clue how long it will take, and I realize that I'm like pretty much the only thing between you and beer, so I'll try to keep it short anyways. So let's get started. I'll be talking a little bit about MongoDB and Python and how you can use both together. Who was present at Mark's talk just prior to this one? All right, so a couple of people. So there's a little bit of overlap, but not too much. So let's just jump into the topic. What am I going to talk about today? I'm going to talk a little bit about SQL and NoSQL. NoSQL is a very generic term that I'm always told not to use, so don't take a picture with this word on the slide. I'll talk a little bit about terminology mapping. So how does a document database such as MongoDB compare to a traditional relational database? So I'll cover a little bit about those at first so that you can kind of get a better understanding. Then I'll talk about some of the benefits, and finally I'll show you a couple of examples on how to do CRUD operations using Python on a Mongo database. So before I get started with that, let me introduce myself. So hi, my name is Joel. I'm not that fat usually. It's just a little bit stretched out. I am a little bit of a narcissist though. Like I like to put pictures of myself in my slides. Apart from that, I work as a developer advocate at MongoDB, and I am based in Ottawa, Canada. So that's the little accent that you might notice there. If you ever want to get in touch with me, Twitter is always the best way. I like Twitter. I like to use it. I stay away from the drama on Twitter, but if you ever want to get in touch with me, it's usually the best way. So let's talk about SQL and NoSQL. As I said, NoSQL is kind of a very generic term, which kind of refers nowadays to anything that is not a traditional relational database. And when I first started looking into it, I was like, NoSQL? Like, what does that mean? Like, how does that? And I mean, I've learned, relational databases in school in the last millennium. So I'm kind of used of thinking that way. I have this mindset built into me. So whenever I think of data, I can naturally deconstruct all of the data into different tables, and I'm used to that. So when I joined MongoDB about a year ago, that was like one of the biggest things. Like what I struggled a lot. Like how do I model my data? So I'll give you an example. I have a website. I homebrew. So I make my own beer, like a passion of mine. So if you don't want to talk about database later, but if you want to talk about beer, like I could talk for a long time about beer. So I wanted to put the beers that I have available on tap on my personal website. So if I would have used a traditional relational database, this is what I would have done. Create a table for my beers, which has an ID, unique ID, a name, and just a field to say, is it tapped or not? Is it available on tap or not? And then I can put in my different beers. So I've got my Paranoid Porter, which is currently on tap. If you're using a document database, it's very similar. So you'll create a document which is similar to a JSON object. And then you'll just add a couple of different fields. So you'll have a field for the name, Paranoid Porter. You'll have the is tap. Once again, it's a Boolean. So you can see that you can use different types. So you can use strings, numbers, and Booleans in this case. So that's all good. So I've got my new beer, which is inserted. But now I wanted to add the recipes as well on my website. I want to open source my brewing process. So I wanted to put the recipes in. So how do you do that in a relational database? Well, I could add a new column for each one of the steps that I do, but of course we don't do that, and we all know why, because you don't know how many steps and so on and so on. So what we do is create another table with all the different steps. So I've got 2 steps for that specific beer, so I just mashed the grains and then I boiled the beer. In a document database, this is how you would do it. So you can add an array of all of your different steps. So instead of creating a second table, you can just add this array. In this case, it's an array of strings where I just list all of the different steps. So now I've got this single object that has all of the information about my beer, including the information about the beer itself, and then also the recipe. Now, of course, this is not enough to make beer. You also need some grains. So if you're in a relational database, you need to actually add another table with all of your grains. In this case, I've got a list of different grains that I'm using with the quantities. Those are in pounds. Any home brewers here? Okay, there's a couple. So this is actually my recipe. So if you want to take a look. So this is what it looks like in a document database. So you would just add another array with all the grains in it. In this case, I'm using an array of objects. So I'm using sub-documents instead of an array. So you can see that my object is getting more and more complex. But again, it's all stored into this one single big object, one entity. For those of you who are home brewing, I'm adding my hops here. This is the full recipe, so I'll share my slides afterwards if you want to make the beer. This is exactly the recipe. So once again, same type of thing, the hops, same type of table, name, quantity. There's also boil time, because the earlier you put it in, the bitter it gets, and let's not talk about beer. All right, so now that I've got my entry, I'm very happy with that. Now I want to add a second beer. I want to add my narcoleptic IPA. So again, another recipe if you're interested. So you'll notice that it's very similar. So I'm creating all of those different tables, or all of the entries in the different tables. And I've got like 6 or 7 different grains and different hops and so on. This is the list of hops that I do for this beer. Note that there's one little difference here, is that I'm using dry hop here for the boil time. So in the previous recipe, I was using a number. Because I wanted a number in minutes, but then for the specific beer, I put in the hops at the end of the fermentation process, and I wanted to indicate it somehow. If I was using a traditional database, that would kind of be a problem, because then I would need to change the type of that specific column to be strings, and then I would have numbers inside of a string field, and it's not ideal. In my document database, I can actually just put in a string here. We've got a very flexible schema that we can use. So basically, you could put in different types, different documents that are kind of similar, but you can still put them inside of your database and have access to it. So that works perfectly well in this specific case. All right, so let's add a third beer to my database. So let's add my Megalomaniac Mango IPA. Great beer. As the name implies, there's mangoes in it. So relational database, again, I need to add another table with all of my other ingredients, but I can just add this extra field in here. Now, this is a great, it's a great beer, but it's an IPA, and it's usually very strong, a lot of alcohol in it. And that's the type of thing that I want to know when I'm going to take a beer, because I'm not going to have as many as some of the others. So I need to add this other field now. I need to put in a field for my ABV, alcohol for each one of my beers. Now, again, traditional database, it's a bit of a problem. Now you've got this extra field that you need to add. You might have to go to your DBA and be like, I need to add an extra field to my database. And you want to make sure that all of the development environment all have that extra field, that your staging environment has that extra column, and on and on and on. So you've got to make sure that you keep up to date all of your environments. That could cause some downtime as well in some databases. But fortunately, when we are using documents, you can just add the field at the end of the document, and that's fine. So you don't have to necessarily put it everywhere. In the case of our relational database, we add null for each one of the values, because I don't have the values, but I can just add that field into my document. I'm not sure what I was showing on this. Oh, yeah. See what I said when I added new slides. So if we compare the previous one, which had the other ingredients as well as the ABV, you can see that the two recipes are very similar, but there's a couple of differences. So that's what we mean by flexible schema. So you can have documents that differ a little bit. Typically, you still try to keep it similar, but they can differ, so you have the access to that. If you want to enforce a schema, though, if you want to make sure that all of your documents are exactly the same, you can do that as well. All right. So yes, I was missing one ingredient. I forgot my yeast. So if you're into beer, you know that I didn't have any yeast here. So in my traditional database, again, I could add yeast there. But then that kind of makes it for a weird table, because it's like all the properties of the beer, and then all of the ingredients and the recipes are in different tables. So do I keep it there? Do I keep it in a different table? So it's up to you to decide on how you're going to do it. But again, using a relational database or a document database, you can just add that at the end of your document. So when I was looking at that the first time, I was like, this is very confusing to me. Like I'm used to split all the data into all those different tables. So it took me a while to really understand, when should I put everything as sub-documents? When should I put everything inside that single document? And really, this is what made sense to me. One of our colleagues that mentioned that So data accessed together should be stored together. And we'll see that when we get to the code examples in a couple of minutes, but that's how you really make sense of how you model your data. So anything that you need to display together, you just store it all together into a single document, and then you'll have access to it. So just a little bit of terminology, making sure we're all on the same page. So when we talk about documents in a document database, really what the equivalent in a SQL database would be a row in a table. So if you're coming from the relational database world, this is kind of what it maps to. It maps to that, but it also maps to rows. So you could also have multiple rows. In the example that I've shown earlier, you've seen that I was using all the information from all those different tables into a single document. So a single document is one row or multiple rows inside of a database. When we talk about fields, we generally refer to columns as well, so same type of mapping. So a field is just a key value pair, and it's kind of the equivalent of a column. You do have a little bit more flexibility than a traditional database, though. And when I talk about collections, this is the equivalent of a table, so they just map one to the other. Database, easy, maps to a database. So when you hear MongoDB database or a SQL database, same type of thing. Indexes, there's also indexes in both worlds, so both the document database as well as a traditional database. Indexes are very interesting. I've been looking into that recently, and it's like really cool stuff. If you have performance issues into your database, that's probably some of the way that you can resolve some of your issues. Views are available into the two formats. And embedded documents, that is really what caused me a lot of trouble when I started playing around with MongoDB. So I was like, okay, so now I need to embed everything into a single document. And in the example that I showed at the beginning, it kind of makes sense. Like it's all information about a single thing. It makes sense to group things. But what if I wanted to add something like, oh, who was there or who is the author of that recipe? Then I would embed the user object as part of my object, but then how do I get access to all of my users? So it gets a little bit tricky. So sometimes embedded documents make perfect sense. One thing that you can also use are dbrefs, and typically you would use lookups. They work very, very well. For those of you who were at Mark Stock earlier, you've seen that. Basically, it's just a way to do a relationship between two tables. So I would have my user table still, I would have my recipe table or my beer table, and I could just make a reference to the user ID to show who actually wrote the recipe. Asset transactions, possible for both different types of database, so it is available in MongoDB as well. So let's talk about a couple of the benefits, and I'll go kind of quickly on that. Scalability is one of the nice benefits of, and if you were at Mark's talk, you just said, don't do exactly what I'm going to tell you to do. Scalability is one of the nice benefits. Traditional databases, the more data you add, the more bigger you need a server, and you need to be bigger and bigger and bigger up to a point where it just doesn't make any sense. You can't go any bigger. You can't add more RAM to the machine. So one of the things that you can do with MongoDB is to do sharding and to scale horizontally rather than vertically. So you can just continue adding more cluster instead of growing your clusters. So it can make sense in different contexts. Apparently not all contexts. So, agility is one of the things that I really enjoy. As a software developer, I love the fact that I can have those two different, not very different, but those two different documents. So you see that I've got my first recipe, and then the other one, I just added a bunch of stuff. As I was building my application, I was like, oh, I should add that. So I can just add it to my documents, and then at some point, I'll come back and fix those documents that were created earlier. So I love that flexibility. It gives me a lot of power as a software developer to be able to do what I want to do. So you can see the differences in the two documents right here. Now, I say you can put in pretty much what you want. So you could technically put in your same collection your list of beers, as well as all the users who would be the people that created the recipe. You could. But don't do that. It's a very bad idea. So you want to use that flexible schema if you can, but don't go too far. Like don't go too different in what you're trying to store into the same collection. It is okay to vary a little bit from one to the other. Use it when it makes sense, but don't store all of your information into a single collection. You just won't be able to query your collection anymore. But say you want to pivot, and instead of having all of your beers, you also want to add your bread recipes. Well, those are kind of similar. It's the same ingredients. So you'll have a recipe field. You'll have a name. So it's very, very similar. So you can actually use the same application to store both beer recipes and bread recipes. So that would kind of make sense in that case. An interesting way to do that is by using schema versioning. So you could say, well, this is like my original application. It uses version 1. And then on your front end, you'll be able to display, oh, this is the version 1 of the document, so I'll display this UI. And if it's version 2, I'll display this other component. But most of all, what I like is the developer experience. So if we look at a document in MongoDB and the same document in Python, well, it's the same thing. So I've got my array of grains in this case. So you can see that it really maps. So that now if I want to take that entry from my database, I can just immediately use it in my application. So that is what really, really makes sense to me. Did I say I like to put pictures of myself? Yeah. All right. So it's all about that. A lot of people, that is one thing that I hear. So yeah, it's just a database that saves JSON. Yeah, big deal. Not quite. It's actually using VSON. And again, if you want to learn more about that, come to see me later. I'll be more than happy to talk about it. What I wanted to show is how you would use MongoDB in Python. First of all, you'll need to install the MongoDB driver, so install PyMongo SRV. Connecting to a database, this is the code to do it. I do realize that the contrast is not great. I'll be sharing the slides afterwards on Twitter if you want to take note of my handle. But basically, you just define your connection string and connect to the database using the driver. Relatively simple to do. To get your connection string to the database, if you're using MongoDB Atlas, you can just connect to your server, click on connect, and then you have access to your connection string. So you can just copy and paste it into your code. So this is the code to read a document. So I said I'm going to go through the kind of the CRUD example. So reading an entry from the database is just using so you define your database, define your collection, and then use the find one method. In this case, I'm using the ID. So find one by ID, and I get my object, and I can immediately start using it. So you might think, well, it's kind of the same thing as doing select star from beers, where ID equals beer ID, right? It's not quite the same thing. So if I were to actually try to get that object from my relational database, I would have to first start by getting my beer object from my database, so select star from beer ID. But then I also need to do select star from recipe, because I want all of the different instructions. And then I'll take those fields and then map that or append those to my dictionary. I'll do the same thing for my grains, for my hops, the same thing for the other ingredients. And then finally, I can return the beer. So you kind of have to construct all of that object into your code. And that adds a lot of overhead, a lot of code that you need to add in order to just be able to use that object. So once again, this is the comparison between the MySQL and the MongoDB code. You don't really see it, but essentially, it's the number of lines of code that is interesting here. So it makes it very, very simple to just get that object and be able to immediately use it. And that is, in my opinion, the most powerful feature of MongoDB. If you want to get more than one object, you can use the find method, which it'll just return all of the documents. You can also specify different queries. So in this case, I want all of the beers that are available on tap. So just find everything that is tap equals true. If you need to update a document, like I've worked with relational databases a lot. So this is like what you would do to update a document when you're looking in MySQL. So the first thing, you want to make sure that your object that you're using in your application is exactly the same as your database. So in order to do that, well, first of all, you need to delete all of the grains recipe, hops, other ingredients from all the different tables to make sure that you're updating with the new values. So delete all of that, and then you can start inserting. You'll insert the beer object, and then you'll insert all of the different grains, hops, and other ingredients as well. And then finally, you've got this update statement, which was my worst nightmare whenever I had to deal with SQL. So this is the code. So basically, you've got all of the fields. So update where name equals something, where not where, but set name equals something, ABV equals something, and on and on and on. And then you've got all of those values in an array. And you hope as hell that they're actually mapping to the right value. Because if you mix one or forget one, you get some really weird result in your database. So that was a very, very tricky thing to me, and one of the things that I just absolutely hated to do. And then when you've got a change in your schema, then you've got to make sure that this will actually support it as well. Another thing is that you've got to now make sure that things like the yeast, it might or may not be there. How do you want to handle that into the database? So you've got to take track of all of that as well. MongoDB, this is how you would do an update. So use the update one method, specify the ID. So this is your where clause. And then you've got the just the set property or the set operator. You just pass it your beer object and you're done. It's good to go. So if you've added different grains or removed some objects or some entries from your array, it'll actually automatically update the whole object into the database with one single line of code. So again, kind of a big difference. And like I said, I like to write code. I hate having to make sure that all of my code maps to the recent changes in a database. I just want to go fast and just write the code that has to do with my application. I don't care about everything else. So and other examples, I won't go through the MySQL comparison every time. To create a document, again, one single line of code. So insert one, just pass it to the object. It will automatically insert the object into the database. One tricky thing here, though, is that it will accept pretty much any object. So if you would pass it a user here, it would definitely add it to the database or to the collection. So you might want to do a little bit of validation before you add things in here. Same goes for updates. You could also add schema validation on your server if you wanted to make sure that the data that you're passing to your database is actually valid and something that you want to deal with. Deleting a document, delete one is the method to use with again, with the ID, which is the equivalent of the where clause in SQL. The greatest feature about MongoDB, and once you start to have those operations or this data inside of your database, is using aggregation pipeline. So if you need to query your data, do some analytics on your data, see what's there, map different tables together, you would use what is called aggregation pipelines. So I'm not sure how this is going to come. So say I want to get all of my beers that are on tap, or count the beers that I have on tap. So the first thing I would do is to add a first stage, and this is the UI for MongoDB. It's called Compass. So first I would start by putting a filter. So I say, well, find all of the different beers that actually have is tap true. You could do more complex filters as well, like find all of the beers that have greater than 7.5% of alcohol, for example. So you can really play with that. But what I want to do here is just to get a little, my first filter, and I see that preview in real time as well, so it helps me to build those queries. And then I can just add a count operation, and I'll say just count those fields and return that as beers on tap. And I've got my result here. So this is the document that I would get at the end. And the code, you can just go copy the code from Compass, get the exact aggregation code, and you can copy that directly into your application. You can also add import statements as well as the driver syntax and everything. So it makes it very, very easy to immediately copy your code. And you've got this code, which is ready to you. You can put it in your database. And now, whenever I'm going to run this, I'm going to get the number of beers that I have on tap into that document that I've just shown. All right, so that brings us to the end. So I've talked a little bit about SQL, NoSQL comparison. Hopefully that clarified some of the questions you might have had, terminology mappings, benefits of NoSQL, which are scalability, agility, really my favorite, developer experience, in my opinion, which is so much easier once you get that new mindset and once you're getting used to embedding your documents and not splitting everything across tables. It starts to really make a lot of sense. And I've shown you the examples of how to use with MongoDB. I'll be sharing the slides afterward if you need them. A couple of advice. Once you start using MongoDB, you'll see that sometimes you have some fields that will come back. Embrace duplication across different fields. I've got like 0 seconds left, so I won't go into the details. Embrace the flexibility of the documents, so use it, but don't overuse them. And data access together should be stored together, which is really the rule of thumb that you could apply all the time. With that is all I had. So you can find my slides here. Thank you very much for being
here. Okay, we have a question. Can you share some interesting use cases of GridFS?
Can I share some interesting examples of GridFS? No. Mainly because it's a topic that I'm not familiar with. Maybe, Mark, you have some?
It's for storing large binary blobs in the database. Is there a limit on the size of the document?
Thank you.
There's a limit on the size of a document, and so GridFS is something you can stick on top of MongoDB that allows you to store large binary blobs. If they get over the size of the document limit, then it kind of splits them up, and then when you query them, it puts them back together again for you. It's not something we promote particularly. Our recommendation is if you're storing lots of large binary blob data, like large NumPy arrays or something like that, we recommend that you would store that in an object store of some kind, and then provide a reference to it in the database, because it's just not really what MongoDB is designed for. MongoDB is designed for storing structured data rather than essentially opaque binary blobs. Although it does store those efficiently up to the document size limit if that's something you want to do.
What's the document size limit?
16 meg.
16 megabyte? I think that's correct. I was just testing you.
What are the advantages of MongoDB when compared to Couchbase and other NoSQL databases?
When compared to Couchbase?
Yeah.
I don't have the specifics of any database. I personally just like the product. I like how the drivers are implemented in just about any language, and it makes it easy to just map to native objects. I don't believe that CouchDB has the same type of level of support across all of the, and now I'm like, don't quote me on that, I'm really not sure. I don't like to bash our competition, so I don't necessarily make all of the research that I should to really compare them. I mean, the only real advice I could give you is give it a try, and you'll see. There's a lot of documentation on our website that go extensively on what are the differences. It tends to be a little bit biased, to be honest. But then there's a lot of documentation on Couchbase that will also be biased, so you can kind of compare both.
In what case should we use SQL instead of NoSQL?
So when should you use SQL over a document database? Never. No, I don't know. I mean, I've used relational databases for the longest time, and it worked well for a lot of the applications that I did. So there's nothing wrong in using it. If that is something that you're comfortable with, by all means, don't migrate just because you've heard that MongoDB is web scale. So if it works for you, use it. But I'd say that there's such a better developer experience when using document databases that it does make sense if you're starting a new project to use it.
How can we taste your beers?
So to taste my beer, very easy. You just have to take a plane, come to Ottawa. I'll be more than happy to serve you one. I have a couple on tap right now.
Drawbacks of using MongoDB over SQL?
Drawbacks, well, same type of thing. If one works for you, just use it. I think one of the drawbacks for me personally was the difficulty of getting into that mindset of embedding the object. And I was using MongoDB just exactly the same way as I was using my relational databases. And I ended up not having features, and I was fighting against the database all the time. So that's one thing you kind of need to understand. You need to want to learn something new, because there are some differences in how you're going to use it. But once you start using it, I'd say it's definitely worth keeping using it.
Last one, is Mongo NI's fit for CQRS event sourcing scenarios?
Another question that I'm not sure. So can you use MongoDB for CQRS? I don't see why not, but then I'm definitely not an expert, so I don't know who asked the question, but I'll be more than happy to discuss that specific use case in details over beers.
That's the last question that we had, unless there's a question from the audience. No question, because time is also almost up. So let's give another round of applause. Thank you for.
Thank you.